Have you ever wondered how organic compounds are named? It might seem like a hodgepodge of letters and numbers, but there's an entire system behind it. It's called the Iupac Nomenclature system. Firstly, let's delve into alkanes, the simplest form of hydrocarbons. These are named based on the longest continuous carbon chain in the compound. For example, methane, ethane, propane, and so on, up to decane. If there are substituent groups branching off this chain, they're named with appropriate prefixes and position numbers. For instance, 2-methylpropane or 3-ethylpentane. Next, we have alkanes, hydrocarbons featuring double bonds. The longest carbon chain containing this double bond is identified as the parent chain. Ethene, propene, butane, all the way to andesine are examples. If there are substituents, number the parent chain to give the double bond the lowest possible locants. Moving on to alkenes, these are hydrocarbons with triple bonds. The rules are similar to those for alkenes, with the triple bond taking priority in numbering. Examples include ethyne, propyne, butane, and so forth. Our next category is alcohols, where the longest carbon chain containing the hydroxyl group is named. From methanol to decanol, the names are based on the number of carbon atoms in the chain. The position of the hydroxyl group is indicated with the lowest possible number, as in 2-propanol or 2-butanol. Lastly, we'll look at carboxylic acids. The longest carbon chain containing the carboxyl group is identified. From methanoic acid to decanoic acid, the names reflect the number of carbon atoms. Substituents are named and numbered to give the carboxyl group the lowest possible locants. In essence, the Iupac nomenclature system provides a standard way to name molecules based on their structures and functional groups. Though it may seem complex, with practice and a firm grasp of the rules, it becomes second nature. Remember, alkanes are named based on the longest carbon chain, with alkanes and alkynes following similar rules but prioritizing double and triple bonds respectively. Alcohols and carboxylic acids name the longest chain containing the functional group, with the position indicated in the name. Now, the next time you encounter an organic compound, you'll know exactly how to decode its name.
Organic chemistry, a branch teeming with millions of compounds, presents an intriguing puzzle in naming these compounds. As a fascinating fact, the longest name of a chemical compound in the Iupac system has over 30,000 letters. Now that's a mouthful. Diving into the world of organic chemistry, one might come across two types of names for compounds: the Iupac, International Union of Pure and Applied Chemistry Names, and the common names. The Iupac system offers a systematic and universal way of naming compounds, while common names, as the term suggests, are the everyday names we use, which often lack the systematic structure of the Iupac names. Take, for instance, the compound with the formula CH3-CoOC. In the Iupac system, we call it ethanoic acid, but in common parlance it's known as acetic acid. Similarly, the compound CH3CH2OH is known as ethanol in the Iupac system, but it's commonly referred to as alcohol. The key to understanding Iupac nomenclature lies in recognizing the longest carbon chain, the type of bonds, and the presence of functional groups. The system uses prefixes, suffixes, and numbers to indicate the specifics of the compound. But why is knowing this nomenclature practical, you might ask? Well, it's essential in many fields. In medicine, for instance, understanding the Iupac names helps professionals identify the molecular structure of drugs and their functional groups, which can predict their behavior in the body. In the field of research, Iupac nomenclature is indispensable. It helps scientists communicate clearly and accurately about specific compounds, avoiding any confusion that could arise from the use of common names. Even in industries such as oil and gas, pharmaceuticals, and food and beverages, the Iupac system is crucial as it allows for precise communication about the substances involved in various processes, contributing to efficiency and safety. In essence, the Iupac nomenclature serves as a universal language among scientists, professionals, and students alike, providing a clear and systematic way to identify, communicate, and understand the vast world of organic compounds. So, the next time you come across a complex-sounding chemical name, remember it's just the compound introducing itself in the most detailed way possible.